The turning moment diagram for a petrol engine is drawn to the scale. Turning moment 1 mm is equal to 5 Newton meter. Crank angle 1 mm is equal to 1 degree. Areas above and below the mean torque are 295, minus 685, 40, minus 340, 960, minus 270 mm square respectively. Mass of rotating parts is 36 kg at a radius of gyration of 150 mm and engine speed of 1800 rpm. It is a common data question. It consists two questions. So first question is maximum fluctuation of energy of the flywheel in joules is. Maximum fluctuation is nothing but the difference between the maximum energy occurs and minimum energy occurs in a cycle. So consider second question that is given by coefficient of fluctuation of speed is. So here the options are 3%, 0.3%, 0.03% and 0.03%. Coming to the solution, first draw the turning moment diagram. Let us say this is the turning moment and this is the crank angle. This represents, let us say here it is a crank angle. So a turning moment on y-axis, crank angle on x-axis. Let us say this is the mean torque and just put the starting point as A. Okay, and consider now second point which is having a torque of 295 joules. This is a positive value. Just draw a line on positive side. So let us say this is B and it is a 295 joules. So sorry, it is just 295, just write it as 295. And coming to the second cycle, that is minus 685, so it comes on negative side. Let us say this is minus 685 and next one is 40, it is a positive value and let us say this is, and next one is minus 340, again comes on negative side, and next one is 916, it is a positive value, of course it is a power stroke. So and the final stroke is exhaust stroke, it represented by 270 and it is 960. So let us say these points are C, D, E, F, G. Okay, this is the given turning moment versus crank angle diagram. So from this we can find out the maximum energy stored in the flywheel as well as the minimum energy stored in the flywheel. So consider from the point A to G, let us say at point A energy is E, just simply E. Plus 40 is equal to E minus 350. Now consider the point at E which is given by E minus 315 minus 340 and which is equal to E minus 690. Now consider the point at F which is given by E minus 690 plus 916, so which is equal to E plus 270. Now consider another point, the final point EG, so that E plus 270 minus 270 which is equal to just E. Okay, so they are the different energy stored at different points. So maximum fluctuation of energy is equal to the difference between the maximum energy stored in the flywheel and minimum energy stored in the flywheel. So now consider the maximum energy stored in the flywheel is energy is equal to, here it is E plus 295 and minimum energy is it is E minus 690. But here the the scale factor is given by 1 mm is equal to 1 Newton meter, sorry, here 5 Newton meter, and on x-axis 1 mm is equal to 1 degree. That means pi by 180. So that here the maximum fluctuation of energy is given by E plus 295 minus E minus 690. So which is equal to 985 mm square. And here 985 into 5 into pi by 118, and which is equal to 86 Newton meters or joules. Okay, this is the maximum fluctuation of energy, and in the options answer is B. Second question, that is coefficient of fluctuation of speed. Here coefficient of fluctuation of speed is given by, let us say Cs is given by del E by I omega square, where I is equal mk square omega square, because I is a mass moment of inertia. So that the final value of coefficient of fluctuation of speed is 86 by, where mass of the flywheel is, rotating parts is 36, and radius of gyration is 0.15, and the speed is given by 188.5 square. Here omega is equal to 2 pi n by 60, and the value of 2 pi n by 60 is equal to 188.5. So the final value of coefficient of fluctuation of speed is 0.003. So that is equal to 0.3%, and in the options answer is B.